Hi, my name is Jennifer Strang from the Dalhousie GIS Center. Today's quick tip will be on accessing Sentinel data and bringing it into ArcGIS Pro. So what is Sentinel data? Sentinel data is satellite data acquired by the European Space Agency. There are a number of missions that are encompassed within this Sentinel data. To date, the most common are Sentinel-1, Sentinel-2, and Sentinel-3. But there are also additional Sentinel missions, including Sentinel-4, Sentinel-5, Sentinel-6, as well as Sentinel-5 precursor. There are also an additional 6 missions in development. The main mission of Sentinel data is to monitor the Earth's surface for conditions and how it's changing through time. So more on what is Sentinel data. Sentinel-1 data is synthetic aperture radar detection. It penetrates the cloud and can be used at night because it is an active sensor, meaning it actually produces its own energy and looks at the reflections coming back based on the energy that it's sending out. Sentinel-2, on the other hand, is a multi-spectral, high-resolution satellite. It is a passive system, meaning it's just looking at the reflectance based on the sun's energy. It is high resolution and ranges from 10 to 60 meters. Sentinel-3 is global in scale. It focuses on land, water, and the atmosphere. It is a combination of both active and passive devices on the satellite constellation, and it has varying resolutions. This session will be focusing on Sentinel-2 data. Focusing in on Sentinel-2 data, again, this is a passive multispectral system. It contains 13 bands ranging in resolution from 10 to 60 meters. When you look at this data, there are 3 product levels that are available. There's level 1B. This is top of atmosphere radiances, but it's in sensor geometry, meaning the coordinates might not be as intuitive. Level 1C is also the top of atmosphere, but it's the reflectances, and it's in cartographic geometry, meaning it's in a geometry that makes sense to most computer systems. Level 2A is the bottom of atmosphere, so this is atmospherically corrected surface reflectances, and it is in cartographic geometry, which typically makes it most useful to the majority of people using this data. And this is what we'll be focusing on in this session. As mentioned, there are 13 bands of multispectral data in Sentinel-2. Here's a table indicating the various bands. So you can see that band 1 is a 60-meter band. It's in the ultra blue range of the wavelength, and it's used often for atmospheric correction. It's really good because it can penetrate into water and is sensitive to clouds and smoke and haze. Band 2 is a 10-meter resolution. It's in the blue wavelength, and it's really sensitive to vegetation and aerosol scattering. Band 3 is also 10-meter resolution, but it's in the green wavelength, and it's sensitive to chlorophyll in vegetation. Band 4, also 10 meters, is in the red wavelength, and it's typically used for the built environment and geologic features. Bands 5, 6, and 7 are all 20-meter bands, and they're all in the near IR range and are at the vegetative red edge. They tend to be very good for plant health and crop monitoring, and can, particularly in band 7, be used for determining water. Band 8 is a 10-meter band. It's in the near IR and is really good for determining water and vegetation. Band 8A is 20 meters. It too is in the near IR range, and it is good again for the vegetative red edge and determining water and vegetation. Bands 9, 10 are both 60-meter bands, and these are in the short IR range. Band 9 is good for water vapor and identifying the land-water boundary, whereas band 10 is good for coastal aerosol and looking at the cirrus clouds. Bands 11 and 12 are also shortwave infrared. They are 20 meters in resolution and can be used, band 11 for vegetative health and water content. Band 12 is good for water content, mineral composition in rocks and soils, as well as burn scars. Next, we're going to talk about how you actually access the Sentinel-2 data. So to do this, you're going to go to your browser of choice. Mine is Chrome. Then you're going to go to https://browser.dataspace.copernicus.eu. Click on the login button. If you don't already have an account, please create one. If you do, log in. Then use your mouse and go to the area of interest in the map. Make sure you're on the Visualize tab. Under Data Collections section, you're going to make sure that Sentinel-2 is picked from the drop-down and that Sentinel-2 L2A is also selected. Remember, L2A stands for Level 2A, meaning that is bottom of atmosphere, so it has been atmospherically corrected and has coordinates, cartographic coordinates. You're going to expand the date and enter or select the date you're looking for with the maximum amount of cloud cover. When you select on the date, you'll notice that a calendar will appear. The light gray boxes will indicate the dates where there is Sentinel-2 data in this area. The boxes that have the blue outline will meet your cloud cover requirements. Okay, so you're going to select your date, and then you're going to click Find Products for the current view. Next, you're going to click on the Download Product button. The data that's downloaded is in a zipped standard archive format for Europe, which has the acronym SAFE. And essentially, this is a package of folders. Of particular interest or importance to you is the image data is actually located in a folder inside of this called Granule. The format of the images themselves are in a JPEG 2000 format, and there's basically one for each of the bands. The file mtd_msil2a.xml file contains information about the bands, and that information will be used subsequently to bring the data into ArcGIS Pro. Be aware these files are big and will take quite some time to download, so be patient. Now I'm going to access the data given the tools I showed you. So I've opened my browser of choice. For me, that is Chrome. Then I'm going to go to https://browser.dataspace.copernicus.eu. Okay. Next, we're going to make sure we're logged in. So you can see here in the upper left corner, there's a login. When you click on that, it will bring up a page. If you haven't logged in before, you can do that down here. As I've logged in before, I'm just going to log in up here. So I'm going to click on the login page. And you can see here now has my name showing that I'm logged in. Next, I'm going to the area that I'm interested in. So I'm going to pick Peninsula Halifax. So I'm going to zoom way in. Maybe I'm interested specifically in campus area. So you can see I've zoomed in quite a bit. And this is on purpose here. What I'm going to do next is I'm going to make sure I'm on the Visualize tab, which I am. And I'm going to make sure my collections data set is set to Sentinel-2. And specifically, I'm looking at Sentinel-2 L2A. Remember, L2A is level 2A, which means it's atmospherically corrected and in cartographic coordinates. So next, I'm actually going to adjust the date that I'm looking for as well as the cloud cover. Okay, so to click on The cloud cover, I can just click on it automatically and you'll see the maximum cloud cover. So I'm going to change it from 30% and I'm going to adjust it down to, let's say, 10%. Okay, because I don't want very much cloud cover. And as to the date, I'm going to click on the month here. So I want to deal with vegetation, and the vegetation in the winter is not great, or early spring. So I'm going to change to 2022, and I'm going to look for summer leaf on sort of conditions. So in order to do that, I'm going to select the year as well as the month. So I'm going to pick July. And you'll notice when you look at this, there are these gray boxes. Okay, the gray boxes is when the satellite went over this particular area. Okay, you'll notice that because there's 2 satellites in the constellation, that it takes 5 days for the data to repeat. So if you've zoomed into a big enough area, actually, you'll notice it looks like it happens more frequently, but the path is not identical. Okay, so you can see here, there's these gray ones, and from the 2nd to the 7th, which is 5 days difference. You'll notice that some of these boxes have blue around them. This blue are indicating the one that have met your cloud cover content. So I'm going to pick July 7th. So that has at least no more than 10% cloud cover. So I'm going to click on the 7th. Okay, and from here, it's going to take a moment to load. And it's going to show the data below here. Okay, so if I want to actually get the data, you can see I've opened this pin up a little bit, and you'll see below here there's find products for the current view. Okay, so when it's closed, I don't see it. When I open it up, there's find products for the current view. So I'm going to select that. And you can see there is only one product that meets this criteria. And I'm going to download it. So here's the various buttons. I'm going to click on the download product button. And it will take some time for this to download, but you can see it is already started. So the faster the internet connection, the faster it'll go. So it's going to take a little while for this to happen. Be patient, and when it's fully downloaded, we'll move on to the next step. Once your data is downloaded, you need to unzip or uncompress or extract your data to a known location. Next, you're going to create a new map project in ArcGIS Pro. To do this, you're going to go to the Windows Start button in the lower left corner of your screen. You're going to go to ArcGIS and ArcGIS Pro. This is going to open the software. You want to start a new map project. It's important to give a name to your project, and please pay attention to the path where this new project is going to be located. Then I'd like you to add a new folder into this project. Okay, to do that, you're going to go to your catalog pane on your right-hand side. You're going to go to the folders option, and you're going to select the home folder. You're going to right-click in that home folder and select new folder. I'd like you to call it data. Then you're going to go into your File Explorer app. You're going to copy all of the data from the Sentinel 2 folder. And I want you to copy just the data, not the full path. So you have to enter it and make sure that you're getting just the data and not the full path that goes along with it. Okay. Once you get that, paste it into that folder that you just created. Okay, and the reason I'm suggesting you don't use the full path is sometimes ArcGIS Pro has issues with very long file names. Okay, and this is particularly true with raster data. So by keeping only the data and not the full path where it would be located, it's going to make the path much shorter, and therefore should eliminate some problems that you may run into. Once the data is downloaded, we need to unzip or extract it. So I'm going to go to my File Explorer down there at the bottom. You can see this is the file that I just downloaded. I need to uncompress or extract it. So I'm going to right click and choose extract all. If you use a different extracting program, that's fine, whatever you're most comfortable with. By default, you can see the software that I'm using to extract is going to put the data in the same location as where the original file is. So I'm going to click the extract button. It'll take a moment or two to complete. And when it does, you should have a new folder that is not zipped up. Okay, so you can see, based on the icon, here is the zipped folder, and the one above it for me is the unzipped version. You can see there's no zipper on this icon. If I double click inside of it, you can see there's that .safe format that I was talking about. If you double click inside of here, you can see this is where the data is located. Remember what I told you, the important data sets in particular for us are going to be this granule folder, which contains the JPEG 2000 images, one for each band, as well as this MTD_MSIL2A file. Okay, so this contains information about the project and the bands that we're using to download. If you want to take a look at it, feel free. You can just double click on it and it will open it up in a browser, and you can see it's got information about the data that we downloaded, and as well as the various locations of where the data is. Okay, so we're going to close that for now, and I'm going to start ArcGIS Pro. To do that, I'm going to go to the Windows Start icon, ArcGIS, and ArcGIS Pro. I'll take a moment for the software to open. The version that I'm using for this demo is version 3.2.2. When the project opens, we want to create a new map project. I'm going to give it a name. I'm going to call it Sentinel Halifax. And I'm going to pay attention to the location that this project is being created in. So I'm going to put mine in my downloads folder, but please pay attention to where you're putting yours. It's really important. I'm going to click OK, and I'm going to click OK again, and a new map project will be created. Okay, so once it's finished being created, you can see it's an empty project. Nothing's been added to it yet. It does have the name that I gave it up here. I'm going to go to the catalog pane down here in the lower left corner. If yours is not open, you can go to the View tab and go to the catalog pane here. Okay, but mine is already open. I'm going to go to the folders. I'm going to go to the Sentinel Halifax, the home folder. So you can tell it's the home folder by the little house icon that's on it. I'm going to right click on that. I'm going to choose the new option, new folder. And I'm going to create a new folder in here, and I'm going to call it data. Okay, so it's inside of this folder, and again, we need to put the data that we just downloaded into this folder. Okay, so to do that, I'm going to go to my File Explorer app again. And remember, I only want the data. I don't want this big long path, because sometimes it creates havoc in ArcGIS Pro. So I'm going to go into the location where the data starts, and I'm going to select everything inside of here. Okay, and I'm going to copy it. So right click, copy, and then I'm going to go into the folder that I just created. So remember, mine is on my downloads folder in this Sentinel Halifax folder. So I'm going to double click inside of there. There's the data folder I just created. And then I'm going to right click and I'm going to paste the data in there. Okay, so now I'm ready to move on to the next step. Before we can proceed, we need to get information about the data. To do this, go into the catalog pane on the right hand side, into the folders directory, and then into data, granule, and then you'll see the image name that'll be different for everybody. And inside that folder, there should be another folder called img_data. And then inside of that, choose R10M. So this is the resolution 10 meters. Select any of the files that are there. Right click on any of those files and choose properties. Then take a look and gather information about the pixel type, the pixel depth, and coordinate system. Next, we're going to create a Mosaic raster. This will be empty to start and we'll populate it later. So to do this, you're going to go to your home geodatabase. You're going to right click on that geodatabase and choose New Mosaic Dataset. The geoprocessing pane will open up. You're going to enter a name. I'm going to suggest you give it the name Halifax_Sentinel_July_7_2022. You're going to enter the coordinate system, the product definition. You're going to select Sentinel-2 MSI, multispectral imagery. Under the pixel type, enter the information that you gathered and click the Run button. Next, we need to get information about the imagery data. So to do this, we're going to make sure we're in the catalog pane, so you can see I am here. We're going to make sure we're in folders, and then inside of the name of our project, so mine is called Sentinel Halifax. There is my data folder. I'm going to double click inside of there. I'm going to go into Granule. You can see there's the name of the image that I downloaded, so I'm going to click inside of there. And there's the IMG data folder, and here is where your data is located. I'm going to pick one of the R10 ones. You can see there's the various images. So I'm going to select any one of these. So I'm selecting the band 2 here. I'm going to right click. I'm going to choose Properties, and that will bring up a pop-up. And when the pop-up appears, I need to get information about the pixel type, pixel depth, and coordinate system. Okay, so the pixel type is an unsigned short, and it's 16-bit. Okay, so that you need to know. And the other thing you wanted to know is about the spatial reference and the coordinate system. So you can see this is a WGS 1984 UTM zone 20 north. So that's the information we need. I'm going to click OK. And now I'm going to create a new empty Mosaic dataset. To do this, I'm going to go into my home geodatabase. So you can see there's my home geodatabase, and it's got the little icon indicating it is the home geodatabase. I'm going to right click on it. I'm going to go to New, and I'm going to pick Mosaic Dataset. It's going to open up the geoprocessing window here on the right side. We're going to give it a name. I'm suggesting you call it Halifax Sentinel July 7th, 2022. Okay, so again, so we know the exact date of the data. Again, we're going to adjust the coordinate system, so we're going to use the Select Coordinate System button. In the pop-up that appears, we're going to go to and find the projected coordinate system. So for mine, it was WGS 1984 UTM Zone 20. So that's what I'm going to find. And I'm going to click OK. So for the product definition here, I'm going to pick Sentinel-2 MSI, multispectral imagery. And then I'm going to go under the pixel properties for the pixel type, and I am going to pick a 16-bit unsigned integer, and then I'm going to hit the Run button. It'll take a moment or two, and the data will be created. So I've created an empty Mosaic data set, and you can see because it's empty, it doesn't know where to put it. But it has adjusted the projection to a UTM zone 20. The next step is to add the raster data into the empty Mosaic data set that we created. To do this, you're going to find the Mosaic data set in the catalog, which is in the home GDB. Right-click on it and choose Add Rasters from the pop-up. For the raster type, choose Sentinel-2. For the processing templates, choose BOA reflectance. Remember, BOA stands for bottom of atmosphere reflectance. So that's because we brought in the level 2A data. Okay, we're not going to specify which resolutions, so all the bands are going to come in. Under the input data, leave File, but click on the Add Data or Browse button and choose the mtd_msil2a.xml file that I pointed out earlier. Under the raster processing, check the boxes next to Calculate Statistics and Build Raster Pyramids. Then click the Run button. Now we need to bring in the raster data into our project. To do that, we're going to go to the Catalog pane down here. In our Home GDB, we're going to find the Mosaic dataset that we just created. So there it is. We're going to right-click on that, and we're going to choose the Add Rasters. From here, our raster type, we're going to make sure Sentinel 2 is selected, which it is. For the processing template, we're going to use the Browse button, and we're going to use BOA reflectance. We're not going to specify the resolution because we're going to bring in all of the bands. We're going to leave the input data as file, and then we're going to use this Browse button at the end, or Add Data button, it looks the same. And we're going to go find that file that we just did. So that's again in our folders. Remember, in our data folder that we created. And we're going to find that mtd_msil2a.xml. We're going to click OK. And you can see it's added it. We're going to go down to the raster processing. We're going to check the Calculate Statistics and Build Raster Pyramids. And then we're going to hit the Run button. So this is going to add the data sets into the Mosaic data set. Just to be clear, the data is actually staying where it is, but it's being interpreted through this Mosaic data set, which can be really useful if you have multiple files that need to be brought in together. And it will take care of color matching and things like that. So it will take a few moments, but when it's done, we can take a look at the results. Once the Add Rasters to Mosaic dataset is finished, could take a few moments, could take a few minutes, it is quite large data, your data is ready to go. So if desired, you can go to the Image Layer tab and choose the band combination and choose the desired combination, or use the custom one and adjust manually. If desired, you can also go to the Imagery tab and choose the indices and pick an index that you'd like to try out. It will create an index in memory that you can view on screen. Or you can do any other processing or classification that you desire. Remember though, that not all bands are the same size or resolution, so not all imagery or band combinations will look the same or have the same level of crispness. Now that the rasters are added to the Mosaic dataset, we're ready to go. Remember, when they're added, they are not being copied into the Mosaic dataset, but they're just being organized in such a way that ARC knows how to deal with it and work together. Okay, so if desired, you want to zoom into your area, you can click on your footprint, you can right click and choose Zoom to Layer, and it'll automatically zoom in to the footprint where the data is located. It'll take a second, but it will automatically show your data as a true color composite. So basically this means that it looks as though you would see it with your naked eye if you're flying in a plane at that elevation. Okay. But if you want, you can click on the image in your contents panel, go to the Image Layer tab up here at the top, and you can change the band combination to whatever you'd like. So you can see there's already some predefined ones here, or you can do a custom. So if you want to do the color infrared, which is going to help distinguish between vegetation and non-vegetation, you can click on that, and you'll notice all the vegetation goes to a nice bright red. It takes a moment or two to process because this is all being just symbolized. So you can see the places that are bright red are trees and things like that. And you can see the urban is kind of shown in this gray-blue sort of color, and the water is the gray or the black. Okay. You can also go into your imagery tab up here at the top, and you can choose indices. Okay, so you need to make sure the image is selected for the indices to be working properly. So you can use the drop down and you can pick any of the indices here. So you can see there's lots of different ones that are useful. Probably one of the most common is the NDVI, which is the Normalized Difference Vegetation Index. So I'm going to click on that, and it's asking us which are our near infrared bands versus our red bands. So if you remember back to our table, our near IR band was band 8 and our red band was band 4. Okay, these are both 10-meter resolutions. I'm going to click OK. And it's basically going to create this NDVI image in memory. So you can see the values are between -1 and +1. I'll take a moment or two to be shown on the screen. The values that are closest to 1, which means closest to white, will be the healthiest vegetation. Okay, and anything that's below 0 is basically non-vegetation. So again, you can take a look or try out any of the other indices. You can also do any other processing or classification that you desire. So have fun and enjoy. There were a number of different data sources that were used in creation of this video. Information was gathered from the European Space Agency, from Sentinel Online, from Satellite Imaging Corporation, as well as GIS Geography. A special thanks to Dr. Chris Green in the Earth and Environmental Science Department for sharing his content from his lab exercise for using Sentinel-2 data, without which this video would not have been possible. Thanks again, Chris. If you have any questions or would like to learn more, please feel free to contact the GIS Center. We're located on the 5th floor of the Killam Library, next to Special Collections. My name is Jennifer Strang, and I can be reached at jennifer.strang@dal.ca or 902-494-1386. If you'd like to book an online appointment, you can do that as well. Go to www.dal.ca/GIS and click on the Book an Appointment link. I hope you've enjoyed the session and have fun GISing.